My name is Anders Rehult and I am fingerprinting new physics with CP violation in B meson decays. And what does this mean? Well, I study antimatter. So matter particles, like protons and electrons, have these antimatter counterparts, and both matter and antimatter particles can decay into other lighter particles. Most of the time, these matter and antimatter particles decay in similar ways, but sometimes they don't. And when they don't, we say that we have CP violation. That's this. So the point of this poster is that my colleagues and I have found a way to use CP violation in B mesons, which are a kind of particle, to distinguish different theories of new physics beyond the standard model. For about 8 years at this point, we have these kind of exciting hints in experimental data coming in from CERN that B meson decays seem to deviate from what we expect in the standard model. When a B meson decays, it seems to do so in a way that we don't predict. And in my field, people use these data coming in from CERN and they try to figure out what new physics could be causing this. And when they do this, they end up with two scenarios in particular, which both fit the data better than the standard model. So these are the two scenarios here. We have the blue and yellow one. Now these two scenarios fit the data kind of equally well, and the point of what we're doing here is that we're trying to distinguish them. Right? We're trying to figure out which one is true. In the central plot, on the axis, you have two kinds of CP violation. So two kinds of differences between matter and antimatter decays, right? Currently, the data supports these scenarios equally well. So that's kind of the pickle we find ourselves in. When you plot these two scenarios in this plane, you get these two pretty distinct fingerprints, these kind of unique signatures. So what we propose is that if we can measure both of these things on the axis very precisely, then we can tell these two scenarios apart based on where we land in this picture.